In this video, we're going to look at modeling falling objects, which we use the equation h of t equals negative 16t squared plus h0. h0 is the starting height of the object that it's falling from. The t is the time in seconds. The negative 16 is the acceleration due to gravity. And then the h of t is just the final height of the object. So if I look at number one here, it says for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. We want to write a function that gives the height h in feet of the container after t seconds. So to do this, I know the height of the object, h of t, is going to equal negative 16t squared. That's the acceleration due to gravity. And then I'm going to add the starting height, which was 50 feet. Okay, so this would be my equation. It then says, how long does it take the container to hit the ground? Well, if you picture dropping a container, so draw a little image here. Say this is 50 feet. You're standing here, you drop it, it comes crashing to the ground. If it starts at a height of 50 feet, when it hits the ground, the thing to notice here is that its final height is a zero, right? So its final height is zero when it hits the ground. So what we're going to do is for h of t, we're just going to plug in zero. So I get 0 equals negative 16t squared plus 50. And then I just solve this guy for the time. So I would minus 50 to both sides. That's going to give me negative 50 equals negative 16t squared. I'm going to then divide by negative 16, and I'll get t squared equals 50 divided by 16. So if I take negative 50 divided by negative 16, I get 3.125. And then to get rid of the square, remember you can just take the square root of both sides. Square and square root cancel, and we get t equals the square root of 3.125. So if I take the square root of 3.125, I get 1.77 approximately. Okay, and that's seconds. Okay, so I would expect that this object, if I dropped it from a height of 50 feet, it would take 1.77 seconds, 1.77 seconds to hit the ground. Part C then says find and interpret h of 1 minus h of 1.5. Now remember the t values here, okay, the inputs here are t's, so that's the time in seconds. And this is the time in seconds as well. So when it says interpret, I can actually almost already interpret what we're doing here. We're finding the height of the object at 1 second. We're finding the height of the object at 1.5 seconds, and we're taking the difference. So we're seeing how much has the object, how far has it fallen between 1 second and 1.5 seconds. What was that space? How much ground has the object covered? So to do this, what we're going to do is we're just going to plug 1 into our function. So h of 1 equals negative 16 times 1 squared plus 50. Well, 1 squared is just 1, and 1 times negative 16 is negative 16. If I add 50 to that, well, 50 minus 16 is 34. So you'd have 34 feet is this first number. Okay, so I'm just going to kind of put that in a little like cloud looking thing. Okay, so 34 feet is h of 1. The height at 1 second is 34 feet. Then I'm going to do the same thing with 1.5. I'm just going to plug that into the function. So h of 1.5 equals negative 16 times 1.5 squared. And then I'm adding 50 to that. So if I take 1.5 and square it, 1.5 times 1.5, I get 2.25. So negative 16 times 2.25 plus 50. And then I'm going to multiply the 2.25 by the 16. So times it by negative 16. I get negative 36. And then I'm adding 50 to that. So negative 36 plus 50, that's going to give me 14 feet. Okay. So now what it wants me to do here is it wants me to take the height at 1 second. Okay, that was the 34 feet. And we need to subtract the height at 1.5 seconds, which is the 14 feet. to find the difference. So 34 minus 14, well, that's going to give me 20 feet. It then wants me to interpret what this means. It means that the object dropped 20 feet between 1 second and 1.5 seconds. So I would write the object dropped 20 feet from 1 second to 1.5 seconds. Okay, so over that half of a second of time, the object dropped another 20 feet is what that's telling us. All right, let's go ahead and look at number 2. So number 2 says Niagara Falls is made up of 3 waterfalls. The height of the Canadian Horseshoes Falls is about 188 feet above the lower Niagara River. A log falls from the top of the Horseshoe Falls. We need to write a function that gives the height, h, and feet of the log after t seconds. So we would write h of t equals negative 16t squared, that's gravity, and it's starting from 188 feet. Okay, so that's our equation. It says how long does the log take to reach the river below? So once again, if you think about the falls, right, like say this is my little waterfall here, it's going to fall down, and then I have the river below it. Okay, so if the river's height is 0 and this is 188 feet, it's falling off. The final height 0, so we're just going to plug 0 in for the final height. So we get 0 equals negative 16t squared plus 188, and then we just solve this guy. So I'd minus 188 minus 188, get negative 188 equals negative 16t squared. Divide by negative 16, and I'm going to get t squared equals, if I do that calculation quick, 11.75. And then once again, to get rid of the square, we just take the square root of both sides. We're going to get t equals the square root of 11.75, which is 3.4 seconds. Okay, so we would expect that in 3.4 seconds, the log is going to hit the river below. And then lastly, it says, find and interpret h of 2 minus h of 3. So once again, this is the seconds, right? That's the time in seconds. And this is the time in seconds. And we just want to figure out what's the height at this time minus the height at that time. How much has the log dropped from 2 seconds to 3 seconds? So we just plug in 2 into our formula, and then we plug in 3 into our formula. So if I do that, I'm going to get negative 16, 2 squared plus 188. Well, that's negative 16 times 4 plus 188, right? 2 squared is 4. And 4 times negative 16 is negative 64 plus 188. If I take 188 minus 64, I believe I'm going to get 124 feet. Okay, so that's the first guy here. Oop, I didn't want to put a box around it yet. Just a cloud. And then on h of 3, I'm just going to plug 3 in. So I get negative 16 times 3 squared plus 188. Well, 3 squared is 9, so negative 16 times 9 plus 188. And then if I take 9 times 16, that's going to give me negative 144 if I add 188 to that. So, sorry, 188 minus 144, same thing. I get 44 feet. Okay, and then what it wants me to do is it wants me to take my height at 2 seconds minus the height at 3 seconds. So if I go ahead and do that, that's 124 minus 44. So on my calculator, I'm going to type that in, and you get 80 feet. And then it wants me to interpret what that means. That means between 2 seconds and 3 seconds, so while the log's falling, between those 2 times, it dropped 80 feet. So the log dropped 80 feet between 2 seconds and 3 seconds. Okay, so over that 1 second window between 2 and 3, the log dropped an additional 80 feet. All right, hopefully this video was helpful when modeling falling objects.